हॅलो, गुड मॉर्निंग सर. सकाळी उद्या किती वाजता? सकाळी 11 वाजता. संध्याकाळी चालेल 6च्या नंतर, 6:30च्या नंतर वगैरे. एवढं नको? हो. 5च्या अगोदर. सकाळी किती ते किती आणि म्हणजे कसं ते तुमचं सांगा. हा, ह्याच टायमाला ना सकाळचं? रविवारी नाही ना? रविवारी नको ना? हा हा, बोलेल ना. मला रविवारी दुपारी चालेल. कधी म्हणजे 12:30च्या? कसं आधी एव्हरीडे कसं असतं ते 10 to 12 असतं एक टायमिंग लेक्चरचं, आणि नंतर मग 2 ते 6 असं असतं. ऑनलाईन लेक्चर्स आहेत ना, 2 to 6. त्यांना 10 to 12 आहे या संडेला. तर मग हां, 12 चालतंय. आणि जर इन केस जर मला काही जर रिशफल करता आलं ना, तर मी तुम्हाला सांगेन, म्हणजे आपण सकाळी करतो. हां, इन केस चालेल. बाकी रविवारी ना? सगळे तुम्हाला मिळाले ना डिटेल्स? माझ्या साईडने काय तयारी करून ठेवायची? चालेल, मिळेल का? तुम्ही काहीतरी बोलत होता ना? ऍड्रेस ऍड्रेस बेसिस. ओके ओके. So Rutika, I have seen your, assignment.
Okay, sir.
It is okay. While you have to resubmit it, because yours is also in new edition, so I am unable to check it. So you can, send the screenshot the way Rutika has sent. Is that okay? Are you around? So yesterday we were here. Only 12 students. We'll wait for 2-3 minutes. हेलो। हाँ बोलिए। हाँ हाँ। यस यस। कैसा रहेगा? ये मार्च की है। मतलब अभी तो फिलहाल तो 30 का वगैरह बात 30 का बात कर रही है।
Sama. Ah,
करेगा। अभी
गरम है क्या? क्या गरम है? आणि ते बिस्किट पण घेतात.
थोड़ा 12:30 के बाद फोन कीजिए। हाँ चलेगा। आपका परिचय मैंने दे दिया था। Okay, so have a look on this. If required, you please draw this diagram also. That is, we were discussing this. लवकर आलो. Okay, so this we have discussed. Discuss this. Now, this is what is your bed. This is what is your bed is. This is all visible, no? Rain. The screen visible. Hello.
Yes, sir.
Uh, Okay. Now this is a bed, and this is what is the foundation for this bed. This is a foundation, cement concrete foundation. And why this cement concrete foundation is required, so that it will not vibrate. The machine will not vibrate. Even uh, the depth of cut is increase. Even the depth of cut is increase. The machine will not vibrate. Now this is inclined. If you have noticed, this bed is inclined. Whatever you have seen so far, this bed is horizontal like this. The advantage of this inclination is that it offers a good rigidity, and another advantage is that the flow of the scrap that it chips, the chips falls down under gravity, and the chips can be disposed of also properly. So this is the advantage. One is reduced. Now try to understand this diagram design. Just identify where is the bearing and where is the spindle is.
हेलो हाँ हाँ मैं अरे वैभव ते सांगायचं विसरून टाकली काय फोटो तर झाला नाही ना म्हणून हा
Hello, sir. Sir, your voice is cracking.
हो आताच
Hello, hello, hello. Am I audible? Hello.
Yes,
Yes,
sir.
sir.
You're
Yeah,
audible.
yeah. Any doubt? So now, see now this is what is your spindle is. Now this particular spindle is a hollow spindle. This is your hollow spindle. Now this spindle is mounted in a housing. This is called as the housing. And in the housing you have, this is a housing, and this one headstock. So housing will have a bore, and spindle, there is the outside diameter. So the spindle is mounted with the help of a bearing. So these are the bearings. Now you can see the difference between two bearings here. This is ball bearing, whereas this is your cylindrical roller bearing. This is your cylindrical roller bearing. So you have two cylindrical roller bearings, and you have one ball thrust bearing. So there are two types of loads on the spindle. That is, one is radius along the radius, and another is axial load. This is also called as the thrust load. Also called as the thrust load. So cylindrical roller bearings are used to take the radial load, and these take higher radial load. And the ball bearings, they are used to take the thrust or axial thrust or axial load. The axial load will be in this direction, and the radial load will be in this direction. And because of axial and radial load, there will be a equivalent load, the direction of which has to be decided by calculation. You have to calculate. That is the result. It may not be exactly, I mean, this axial and radial sometimes may not be 90 degrees. So you cannot, calculate just by Pythagoras theorem. You cannot calculate. So there are mathematical models for calculating the various forces, which we have discussed. If you remember, uh, in metal cutting lecture. Then this spindle, this is a hollow spindle design. Now in hollow spindle, you can push the round bar inside. That is the advantage spindle. And at the end, this is for the rear end and this is for the front end. So at the rear end, there is a provision to receive the drive. There is a provision to receive the drive. So यहाँ पे आपको drive मिल जाता है यहाँ से. And at the front end, chuck is mounted. At the front end, the chuck is mounted, in which the workpiece is hold or held. So this is what is your spindle. Now, what are the points considered in spindle design? Because of the higher speeds, the heat is generated. So there is a provision to remove the heat. So your spindle should be designed for proper cooling, either oil filling or air cooling or some kind of chilling arrangement should be there. Then in the motor and gearbox on which the spindle receives the drive, from the motor and gearbox. So there also you have to have a provision for heat dissipation. Other than this, the beauty of CNC is you have temperature compensation devices inbuilt in the control. Temperature compensation devices inbuilt in the control. There were sensors on the spindle as well as on the gearbox on the motor. So these are helpful for compensating the rise in temperature. So your accuracy is not damaged. This is how the spindle will look like. And this is for your milling. Milling machine के लिए है. So everything has been shown here. Just have a look on this. The cooling is also shown here. The bearings are also shown here. Everything is just look it carefully. Just see carefully. So I hope this diagram is clear. This is a milling machine spindle which is rotating. So you have here hybrid roller bearing. You have a thermal shield which is which doesn't allow temperature to rise. You have a roller bearing here, you have a spindle bearing here, and you have built-in motor system. Then there is a provision of coolant to circulate, and the bearings. If you have one bearing here, then you should have other bearing at the end also. That is what you have to remember. There can be two constructions. See, one is this is called as the L frame, and this is your C frame. Hmm? This is your C. This is applicable for your vertical milling machine, vertical CNC milling machine. Then you have drives which are used in CNC machine. Basically, there are two types of drives. One is a spindle drive, and another is feed drive. So spindle drive is for rotating the spindle, and feed drive is for driving the axis. That is X, Y, Z, whatever it is. So, what are the requirements for the spindle drive? This is how the question is asked. Hmm, Describe the criteria for the spindle drive, design criteria. So, first is large material remote drive. So, MRR should be more. So, either MRR should be more or finish should be more. So, if the MRR is required is more, then you need a larger power. Then speed. Hmm, Speed should be infinitely variable in CNC machine. So that's why we prefer DC motors. Then spindle drives, they are microprocessor controlled frequency converters AC motors. That is, if you are using AC motors, then you need to use frequency converters, and that has to be microprocessor controlled. The advantage that can be used to position the spindle axis at any orientation. That is 0 degree, 1 degree, 1.5 degree, or 1 degree, 30 minutes, 50 seconds, like that. Speed drives. Nowadays, again, see earlier we started with the stepper motors. Then, as per the advancement in technology, stepper motors were replaced by the AC, AC motors. Then DC motors. Now again, DC motors are replaced by the AC servo motors. No induction motors are used. Here now, feed drives. So again, what are the different technology feed drives mean? Is you can use DC servo motors. The advantage of DC servo motors is high performance. Then response is good. Useful in prime modes. Useful in prime modes means like prime mode means which moves on itself, on its own. That is what is called the useful in prime modes. Sorry. Then brushless DC servo motors are also available nowadays. Since they are brushless, since they are brushless, maintenance is reduced, as well as the accuracy is also increased, improved. Brushless DC motors का advantage है heat dissipation is good, motor inertia is reduced so that machine motor starts immediately moment it gets a signal and it stops immediately. That is because of the reduced moment motor inertia. Earlier stepper motors were used. Only advantage is low cost and simplicity in construction, were reliable and no maintenance. But accuracy wise, stepper motors are not that accurate. So therefore, stepper motors were replaced by AC induction motors, then DC motors, then again AC servo motors. So far, you must have heard about motors where the output is rotation, that is rotary, that is the shaft, output shaft of the motor rotates. That is, you give input as electricity, that is this, you connect the motor to the electrical supply and then shaft rotates. But linear motors, what happens? You are giving electrical supply and then output may you have reciprocating motions. So the linear motor means the output shaft will reciprocate. Like you must have seen the cheaper pneumatic chipping machines. So there the chisel which is mounted in the chipper, it reciprocates, which is used for civil work. Hmm. So same way in linear motors you get reciprocating output. But linear motors, instead of linear motors, the rotary motors are preferred. Hmm. Then what are the actuation systems? Lead screws. Nobody uses lead screws. It is always a recirculating ball screw and nut. Lead screws are used on your conventional lathe machine. Recirculating ball screw and nut adds, the backlash can be controlled, and the friction is very less in recirculating ball screw and nut. So there are three types: high, medium, and low. This types is not much importance. Only what you can remember. Even this acme also is not of importance. Only you have to remember that in case of CNC, you have recirculating ball screw arrangement. Recirculating ball screw arrangement. And this is how it looks like. Recirculating ball screw and nut arrangement. This is a ball screw, and this is what is your nut is, and the balls they move across the gap. The balls move across the gap, and if you can see, this is semicircular. So semicircular in the screw and semicircular in the nut. So that forms a circle. So the ball moves, and the gap between the ball and the nut, there will be two gaps. One will be between the nut and the ball, and another will be between the ball and the screw. So that gap is set while dispatching the machine from the factory. That is factory set, and that is what is called as the preloading. So we say preloaded ball screw and nut. Preloaded means in the factory itself, when the machine is assembled, the backlash or the gap between the screw and nut is adjusted, and that is generally lifelong. It remains as it is. It doesn't change. Maybe in major overhaul or in major preventive maintenance, after 5 years, you can adjust this. Or in case of accidents, अगर मशीन ठोक दिया तो that time तो आपको पूरा machine reassemble and re-inspect करना पड़ेगा. So that time you need to do this adjustments. Hmm? This is how motion means like this. It is reciprocating. So these are the linear motion system or anti-friction guideways and anti-friction. Anti-friction means frictionless. Friction is minimum. Friction is zero. The advantage of anti-friction guideways is it gives very high rigidity, very low friction. See, no friction. You cannot say no friction. There will be minimum friction, and there will be less wear and high accuracy. This is what is your ball and nut arrangement, or we can say ball and bush arrangement. Then there are two types of control system. This forms the part of your control engineering. One is called as the closed loop control system, and another is called as the open loop control system. Just have a look on this. So what happens in closed loop control system? The feedback is given to the motor. That is, suppose if we give the command Z01X100. So whether that 100 mm has been achieved or not, that is continuously checked, and that feedback is given to the motor. Like 99, it has 99. So still the motor has to rotate. 99.5, still it has to rotate. 99.99, it has to rotate. And moment it comes 100 mm, it gives the signal of stop. That is, the error is zero. So this is how the block diagram is. Hmm. So there are two kinds of feedbacks here. One is your position feedback, and another is your velocity feedback. This is your position feedback, and this is your velocity feedback. These are the devices, encoders and linear scales. So encoder will check the rotations of the motor. See, finally, this position will be determined by the rotations. Like suppose if the pitch of the ball screw is 5 mm, and if my position if I have given as x100, so how many rotations should happen of the motor? 100 divided by 5, so 20 rotations. So the encoder will check whether the 20 rotations has happened or not. Moment the 20 rotations has happened, it will stop. It is something like, say, in car, I want a speed of say 3000 rpm. So again, there also you have a feedback system. So if it is say 2500, if it is running at 2500, then it has to accelerate. That means it takes a decision or it gives a signal to the carburetor or to the FI pump, fuel injection pump, that more fuel has to be supplied. If the RPM exceeds, that is say more than 3000, then to stop or to reduce the fuel supply. So same thing here. So on the servo motor, you have encoder, so that gives the position feedback. Basically, encoder measures the rotations, and in turn, it will give the whether it is 100, 150 as per the programmed command or not. Another device is tacho generator. So tacho generator is used to measure the velocity, that is your cutting speed, whatever you give. If you are using high speed steel, then it is 25 meters per minute. If you are using carbide, then it is 150 per meter minute. So whether 150 meter per minute, that feed rate has achieved or not, so that tacho generator. So you have OPM or OM, that is operation amplifier, to amplify the signals. Then here there is a comparison, that is what is the feedback velocity and what is the actual. Like suppose actual may you have given say 50 millimeter per second. This is what is programmed, it's 50 millimeter per second, and tacho generator has checked and it will give the feedback of say 45. That current velocity is 45 millimeter per second, whereas the programmed is 50. So there is an error of 5. So that is what is called the comparison. So that signal of 5 plus or minus. If it is more, plus. If it is minus, if it is less, then it is minus. So that signal is given to the amplifier, then it is amplified, and then it is given to the servo motor, and the motor is rotated like that. Hmm? And same is for the position repair. Same. It continuously it keeps on checking with the programmed command. Continuously it keeps on checking. Remember, you cannot have encoder as well as tacho generator both simultaneously. Either you will have encoder or you will have tacho generator. If you don't have tacho generator, then encoder will calculate the rotations, will check the rotations, and then that rotations can be converted into velocity, and then velocity is compared. And same way on velocity also you can calculate the rotations, and then this signal is on the motor is given to the machine tool, machine tool, and machine tool table is moved. Right? Then there are linear scales also mounted on the machine tool. There are scales mounted on the machine tools which are used for measurement, which are used for measurement. So either you can have encoder or you can have tacho generator or you can have linear scale also for the measurement purpose, for the measurement of the position. This is how the encoder construction is. In a simple way, this is given in PN RAW. In a simple way, this is the disk. It has a board which is mounted on the motor shaft. Then these are the slots. These are the slots, you know, trapezoidal slots. That is hollow. In between, this is solid, and there is a optical device. So how rotation is measured? The light is passed through this hole and not passed. It is either passed or light is blocked. So depending upon that, the rotations are calculated or measured. Now, encoders can be of two types, either absolute encoder or incremental encoder. And generally, encoder is rotary. So rotary encoders falls in two categories, that is absolute and incremental. How the encoder is mounted for the position measurement. So this is what is just a machine tool. ये आपका टेबल है. Then you have a lead screw here. So lead screw or more appropriately ball screw. So it has a motor fitted here, servo motor. At the end you have encoder. So encoder gives the position feedback to the machine control unit or to the comparison, the control system which I showed you 2 3 slides before, where you saw that amplifier, that triangle or a symbol. So there it is compared and adjustments are done and the signal is given to the servo motor. All this comparison etc. that is shown here is this is what is your machine control unit. This happens here. It is MCU. Now here instead of encoder, see either you can have encoder or you can have tacho generator or you can have this optical scales or linear scales. So linear scales are also used for measuring the position of the table and it gives the feedback to the MCU, machine control unit. MCU is nothing but the computer, built-in computer. Then sometimes you have glass scales as a feedback devices. Now these glass scales were used earlier, but then there were a lot of maintenance issue hmm, regarding the breakage of the glass, and spoilage of the glass, and coolant hmm, and dust seeping, which used to lead to inaccuracy. So at present, glass scales are not used. So either an encoder or tacho generator, or rather, I will say encoder is used. So this about CNC hardware. From examination point of view, here write short note on encoder, then write short note on axis drive, write short note on spindle drive, and write short note on structure or the bed of CNC machine. So these are the 4 questions which are important. One question will definitely come. We'll go for next now. So we are done with CNC principles, CNC special features, and CNC hardware. Now, any machine is of no use if you don't have proper tooling. Hmm. So again, CNC tooling is also a vast, but we will try to cover up as much as possible within given time. Okay. I hope you have seen this. So this is your insert and this is your holder. This is very important. This is a repetitive question, that is explain the ISO specifications for CNC holder or CNC insert. So the top one is for the insert and this is for the holder. By now you know isn't what is holder, what is insert. I'll explain this. Before that, let me show you some inserts or holders. How does it look like, so that you'll have clear idea. I actually wanted to show you the video also. Let me see. I can show you the video first, so that you'll want to know. Before I go for the CNC tooling, it's better that you see video. You see where it is. Here. Just a short video, the beautiful video. Let us see this video. See, this is a component to be made, and this is your workpiece. This is a finished component, this is a raw material. See, these are the tools, and this is your control.
today.
So this machine is called as the CNC turn mill, and this is what is your CNC tooling is. So you have a holder here and you have a cutter here. And there was a tool changer, automatic tool changer. You saw just 1 minute. See, this is the engraving operation. So you can do it. This is your cutter, CNC cutter. This is a coated tool. This is for the teeth cutting now. Now the teeth are being cut. If this particular machine is your CNC turn mill, this was your CNC turn mill. See the beauty of this CNC turn mill. Otherwise, you had to do, you have to use at least 3-4 machines in order to complete this component. Okay, so we'll continue this next time.
Thank you so much. If you have doubt, please ask.